We have Aaron Harper, like I mentioned, coming to you from Walsenburg, Colorado, where he built a ground station that will let us listen to satellites. Aaron, can you tell us about what you have there?
Yeah. Well, first of all, a ground station is it's a device which allows you to communicate with satellites and other spacecraft, and communication is one of those fundamental things that makes us human. And it should really come as no surprise that it's a fundamental part of getting things done, resolving issues, and it's necessary for a reach into space. It also helps us feel connected to man's efforts to explore. We're no longer the spectators in this global game. We can actually have some small part of it. Ground stations are actually three different things. They're a radio receiver and transmitter. They're an antenna system, and they're also a computer with software to predict where the satellite's going to be. The receiver that we're using is a very small device. It's a TV dongle that is used to receive broadcast TV, and with the appropriate with the appropriate software, which is open source, you can turn it into a fairly powerful receiver, which is capable of receiving those signals that we talked about. NASA spent tens, if not hundreds of thousands of dollars for these things back in the 70s and 60s, and we can pick it up on eBay or Amazon for 10 or 20 bucks. I love the future we're living in, but where's my flying car? The second thing was the antenna system, because one of the criteria was that it had to be able to be transported without the use of a tractor trailer. It also had to be omnidirectional, because adding a tracking system adds weight and complexity. But the interesting one is that satellite signals are not like TV signals or radio signals that are polarized vertically or horizontally to the ground. As the satellite goes through its motion, its antennas actually move relative to the ground. So they had to use a different type of polarity called circular polarity, which in turn makes things look a little bit different, as you can imagine. The unit that we're demonstrating today, it works on the UHF ham radio band, which is where most of those satellites are. But the interesting thing is that the design can be scaled up or down just simply by changing the measurements. It's all a matter of ratios. Finally, that comes to the prediction system, which is using a fairly common PC hardware and some free open source software. We can predict pretty much all aspects of the satellite pass. And this is one particular example. You can see a satellite already in the process of passing, and in the screen you can see the relevant data. That'll give us the distance above the horizon, the compass heading, which is the azimuth and elevation, its operational frequencies, and the expected Doppler shift. And with these things, we can actually make a very good connection to the satellite. And just for the record, this is the antenna itself, built out of very common hardware. Grand total of parts is under $100, and it will pick up most anything in the UHF band, and if you scale it up or down in VHF and L band respectively as well.
Hey Aaron, would you remind us what examples of communications that would be on VHF or L band versus the UHF band?
It kind of depends. What the planners put and what they put where. Most of the time, your voice channels are going to be a downlink. In other words, coming from the satellite to the ground is going to be UHF, which is pretty much the most interesting part because you'll be listening to other people talk. But you also hear things on VHF. That's usually the uplink. The exception of that being ISS, which is VHF up and down. They're just using two different channels. And L-band is in the 1 to 1.2 gigahertz range, where a lot of the telemetry, slow scan TV, and other things are. So if you're of a technical mindset rather than want to hear people talk, that gets fascinating fast. The result is that we can, be involved with space, and it's, we're able to build something out of common parts that we would get out of Home Depot, and using our computer and things we pick up on Amazon. And listen, now since it's a receiver, no license is required. You do not require a ham radio license to pick this up. It's completely legal. No men in black suits are going to beat down your door. The other thing is that this is going to be part of a system that will continue to grow. The next versions, version 1.1, what we're looking at, will be operating at multiple frequencies. Version 2.0, we're looking at being able to transmit as well, which will require a ham radio license. And all the plans and documentations will be available on the Open Design Engine at the website shown on the screen, which will include all the plans, the build sheet, and pictures of the thing going together. And
of course, the project name, Ground Station-001, GS001. It's very, very engineering.
Thanks, Greg.
You're welcome.
And without further ado, now we are having a little bit of technical difficulties with the radio itself. So, but everything else was working, and it was working for a while until I tried to do a Microsoft update and lost the USB driver. So I will simply play a recording of what I got earlier.
California, 1790 WK, 5 DK, good evening, Patrick, Delta Mike 91, good signal. Delta Mike 23 and 24, still in California. That's true, thanks for the group. WD9EWK from Delta Mike 23 and 24 in Southeast California.
Now these radio contacts that we're making here, they're in Arizona, California, and there's a couple faint ones from the other side of the Mississippi. One was in Louisville, Kentucky, and one was in a, if I understood correctly, around the Nashville area.
And just for everybody else, that's actually using the hardware that he showed and the computer that's sitting there with the software. That would be open source, freely available to anybody else to use. You too could have your very own satellite ground station.
Yep. And I'd like to open it up if anybody's got a question on how things work or what software is available. Just let's hear it.
We got a couple of questions here from Bucketworks.
Okay.
There's the camera.
Oh,
And the
yeah.
burrito.
I've been playing around with the Realtek SDR at home. One of the problems I have is the noise floor is really high. Are you guys using the? I just kind of walked into the room, so I missed most of it. But is this the FunCube or Realtek SDR? And do you guys have any experience with bandpass filters?
What I'm using is it's a Realtek SDR with the Elonix tuner. The software that we're using has some noise blanking that I can use both in the IF section and RF. The other interesting one is that I get a significant amount of gain with this antenna, and it pounds out that noise floor pretty good. The actual gain, as far as what I can tell, is approaching 8 dB.
Everybody here was suitably impressed.
Yeah, so was I when I did the math.
All right. Any other questions, Bucketworks or online folks?
I put out an offer for questions over here, and I don't know that there are any, although you might ask the folks at Club Siberia specifically. Andrew from there might have a question. It's not clear to me.
Well, one quick follow-up. Right now we're using Windows software, but this was not my intention. We were having a little bit of an issue with some prerequisite software compatibility, specifically Perl. They switched versions on me. So the actual design, when it gets kitified and the kits become available, which that is another thing, we're going to make these available as kits. We're going to encourage people to use Linux and New Radio, just simply from the standpoint of the flexibility of the platform.
I do have two more questions from cyberspace. One is, what is the estimated cost for the parts of the transceiver? That's from Andrew. Thanks, Andrew.
Well, the transceiver that's the big question. The receiver was the $10 to $20 TV dongle, the Realtek with the Realtek chipset. The transmitter is the one that's going to take a little bit of engineering, and my goal is to have that and be able to put the whole package together for under $200, making it what we here at Mach 30 call a level 1 kite.
Okay, we have some follow-up questions to that. What is the screen for under the ball-shaped part of the receiver?
That is it's a ground plane, and it actually gives a lot more gain that way. Without it, you make without it, with the antenna the way it is, you basically double your signal. But 8 dB is approaching. It's somewhere in the neighborhood of a multiplicative effect of about 6.5 to 7. And the reason is because of that ground plane. It allows the signal to differentiate a lot better.
What material is it?
That's the funny part. Everything here is available at Home Depot or Radio Shack. Yeah, nothing is unusual, and the screen is actually aluminum window screen. And to fasten it to the aluminum struts, about the most conductive thing you can use to fasten window screen to more window screen is staples.
All right. Is this project doable for the non-engineer with limited soldering skills? Asks Julie Fowler.
Julie, let me tell you, the way this one went together, I've got some burns on my hands to prove that it's not the easiest thing in the world to put together. However, what I'm aiming to do is make the kit version much simpler to put together with a screwdriver rather than a soldering iron.
Excellent. And Andrew also asks again, why do we need the ground screen?
It gives you a lot more gain and picks it up out of that noise floor that we were talking about with the other makerspace.
Okay, I think
Right,
the only other thing we've got from out here is, could you talk for a minute about the ways to talk to, or at least listen to, ISS with this ground station?
Okay. With ISS, they're all on the VHF band.
That would be the International Space Station.
Correct. This particular beastie will not. It's at a different frequency, but like I said, to get on different bands, all you do is scale things up. Now, as you go lower in frequency, things get bigger. And in the case of ISS, instead of at 430, 435 megahertz, they are at about 148, which means that that hoop at the very top, the two loops that are at right angles, are about 3 feet across. So it's one of those things that you have to take care of walking through doorways and so on. You don't quite need a semi yet, but you're getting there. So for space station reception, that will be one of the things that I'm going to be shooting for with version 1.1, because that version will be able to pick up VHF for the space station, as well as satellite uplinks, where you're talking to the satellite or talking to a person who is going to receive the bounce signal, the downlink signal.
And I have one more question from cyberspace. David DeBrota asks, what will happen if two different persons attempt to transmit from positions on the Earth to the same satellite at the same time?
It's just like if you were to transmit on the same channel. You kind of ride over each other, and pretty much nobody gets in. It does happen. With amateur radio, we try our level best not to step on each other, especially if somebody with a 1,000-watt rig, and he knows there's somebody out there with a little 5-watt handheld. He tries to be very, very cautious about that and tries to give the other guy a chance. But it does happen, and if you've ever heard two people talk and all of a sudden one of them sounds like an absolute, like a motorboat, or you can't hear a thing, that's what happened.
All right. They keep coming in. If at any time I need to cut off questions, let me know. But
I
Julie
think we can take one more.
also wants to know, does the satellite have to be in line of sight, so to speak?
That is
Yes,
a great question, Julie.
Yes, it is. Very good question. And in fact, that is one of the things that we had a problem with here, because while I've got a great view to the south and to the east, behind me to the north, I have this basaltic intrusion, which is rather high in iron content, which basically means if I have a satellite coming up over the horizon to the north, it has to be somewhere in the neighborhood of 40 degrees up for me to see it. So absolutely, you definitely need line of sight.
And that's why we use the prediction software to predict the tracks, correct, Aaron?
Precisely. In fact, if we go over to the prediction software real quick, you will see these hoops around the satellites. And what you see there in the world map are what we call the footprints. Those are the areas where the satellites are actually visible from the surface of the Earth. And down in the lower left, you see what they call the polar plot, which tells you where the satellite is coming up. For example, AO51 came up to the south-southeast, and looks like here in about a couple of minutes, probably about 10 minutes after the hour, it's going to literally be directly over my head. But the line of sight, that's why those two displays are so important on the prediction software.
Very cool.
I am, for the moment, out of questions here in on the event. But if people were to ask more, Aaron, would you be willing to go in and answer them via chat later? So
Absolutely.
that people, all right. So we're going to stop then with live questions. But if you think of something throughout the day about the ground station, Aaron will come in and answer to your heart's content afterwards. So feel free to keep the questions coming.
Thank you.
Very good.